Okay, for the next problem, we are to design a vending machine with quarters. Only difference is basically inputting the quarters and then having the extra states that will output 1 nickel for every cycle that the change remains high. So going to our state diagram, again, pretty much the same as above. However, the only difference is if we're in state 0 and we have a quarter, the only difference is the implementation of quarters. So for example, if we're in state 0 and we have a quarter, we would proceed to state 5, and from state 5 if we input another quarter, that would be 50 cents. So we'll move to our added state of state 10 where we're vending the item and also giving change, and then following that we'll go to another state where we're only vending change, so state 13 for example, and then moving back to our original state. So that's just an example, as you can read the rest of the other examples in which we have quarters implemented into our existing states as well as our new states, such as state 12, 14, 15, 11, 10, and 13. So going to our code, again, starting at the top, libraries, entity, input, output, port. So we have our architecture. We have 16 states in this case, and here we move on to the beginning where we are proceeding to the next stage on the rising edge of the clock. Again, in our first case, or in our case statement, when we're in our initial state, we don't have vending or any change given. Again, those were the outputs. Stay in the previous video. If a nickel is inserted, we move to state 1. If a diamond is inserted, we move to state 2. And then a quarters is inserted, we move to state 5. So again, the only thing that's really changing is our implementation of the quarters. So that kind of carries on throughout the code with just the quarters. We're in state 1, we'll move to state 6 if a quarters inserted, and so on. The new stuff comes in where right here when we have like state 10 and everything. We have state 10 where dispensing and changes given. Moving on to state 13 where again only changes given because we still need to give the excess change that's left. And after the change is given, we move back to our initial state. So again, throughout those other examples, just kind of follow suit. And we're just routing our outputs or our signals together. And yeah. So ending architecture. So then for here, there's our test bench. Again, we're just inputting our FSM component, routing the signals and the ports together. And then I chose to have kind of like the last one where we have only nickels and only dimes. So I have that still running to show that it still can perform that operation. But then here we have an insertion of quarters only, and that will get us to our vending states. So we move on to here, we have our dimes and nickels. So at this point here, we have our dimes being inserted until we get to the certain amount, and then bins, resets, going to our dimes. We have our dimes a certain amount, and then gets to here and bend. And then now we have our quarters inserted here at this state. It doesn't take long for us to get to vend there because our 50 cents as well as our change is given. And then our change will continue to be given in the next clock cycle because it's 50 cents and we have to give back 10 cents instead of just 5. And then the simulation pretty much just resets with our nickels going in and vending again. And that's it.